actually using this one?
Yeah, we got that.
Hello, everybody. My name is Steven. This is Sean.
Hello.
We work at Dropbox. We're both on the mobile engineering team. Sean works on Mailbox. So today we're going to talk to you a little bit about how Dropbox is tackling the problem of building mobile products for scale. So if we think about Dropbox, the product, it's pretty simple. It's just a magic folder that syncs to all of your devices. And the beauty of Dropbox is that it works in a cross-platform agnostic way. And that product, the very simple magic folder that syncs your stuff everywhere, has brought us a lot of success. We had 100 million users last November. And today, less than a year later, we're at 200 million users. So the growth has been really tremendous. And one of the things that we've noticed is as users get more and more of these devices, I mean, 200 million is nothing compared to the 1 billion devices that are in the world. The users have their data siloed in all of these different applications and on all of these different devices. And this problem is just going to continue to grow as more and more of our day-to-day usage with technology has personal user data stored within it. So as we have gadgets in our car and in our kitchen and so on, we may need a place that kind of ties them all together and is the fabric that keeps all of the data together. And that's the vision for Dropbox. So if you look at the mobile apps that we have today, we have the two major platforms, Android and iOS. And in building these two applications, we've noticed that a lot of the data and a lot of the logic backing the application is exactly the same. So really, we want to create these mobile products where you can view all of the metadata for all of the files that are in your Dropbox. You want to be able to pull down those files on demand and cache them and favorite them and things like that. And then we want to provide some features on top of the file system, like the Photos tab, that allow users to look at all the photos that live in their Dropbox and curate sets of them to share privately with their friends and so on. And one of the big features for these two apps is this automatic backup, where we scan your camera roll and automatically back up all of your photos to Dropbox. And there's a fair deal of complicated logic to get that right. And the way that we've built this stuff is independently as two separate code bases. So we've always been building for native. We've always been building Java for Android and Objective-C for iOS. And what we've noticed is a lot of these hard problems that we're solving, dealing with high latency, low bandwidth, intermittent network connectivity, all of the problems that you're familiar with as mobile developers, we've been solving twice and trying to get right on both platforms with two different sets of developers. And if you take a look at what's shared between the two, there's a whole lot of the code that's shared. So we've got request and response handling. We've got all of this retry logic around what to do in the case of network failures, batching requests so that we can deal with the high latency environment by, when fetching thumbnails, instead of pulling down just one thumbnail at a time, pulling down blobs of thumbnails, so that high latency cost that you pay to establish a connection to the server isn't lost for a low payload, a low bandwidth payload. Just like JSON parsing, caching all that data into SQLite or some database on the phone. And then one of the big ones is actually allowing the user to operate on their data. So delete photos, delete files, rename files, things like that. The canonical solution to this problem that you see in mobile apps today is to just block the user and try to sync that action to the server immediately. And if there's no connectivity, put up an alert that says, hey, you can't do that. Do that later. So in short, we have this entire data model of pulling down all of the information from the Dropbox server, caching it locally, optimizing all these network requests and the logic around when to prioritize them and when to schedule them, and then actually trying to build something a little more intelligent around syncing user actions that are taken on the device later. So getting this stuff right once is hard enough, and by building this in two separate code bases, we've added to our requirements by forcing ourselves to get it right twice. So this means we have the obvious stuff, twice the development cost, twice the maintenance cost for these two different code bases. Subtle differences in behavior. If you have two different engineers working on the same feature for the two different platforms, if they're not in constant communication about the way that they're implementing something, they may come into an edge case or some kind of error handling logic, and they might choose to implement it differently. Or they might choose to implement some kind of user edge case differently. And those kind of subtle differences in behavior add up because Dropbox, at its core, is trying to be consistent across all the different platforms, so that if a user does switch from Android to iOS, they pick up the iOS app and they can just continue where they were and understand how to use the application, and all of the same user interface affordances and so on apply on the other platform. It also means things like bugs that exist on one platform but not the other, or bug reports that come in for one platform and are fixed on that platform, but not necessarily communicated and fixed on the other platform. And then there's, of course, the problem of performance optimizations, where you can spend weeks optimizing a core data stack or optimizing the way that you load out of the database for Android, and all of that effort will only benefit the one platform. So it seems like there's a better model here. And what we've been working on recently is this idea of a shared library called libdropbox, where we can try to implement all of this logic just once and share it across the platforms. So the dream of this library is write once, run everywhere, which we've heard over and over again as the dream. And we've seen on mobile different attempts to have this kind of a solution from a top-down perspective of let's build PhoneGap, let's write HTML code, and let's try to apply it to both platforms. And we've all seen that, at least in the current state of the world, that's just not good enough. The performance there suffers. It doesn't feel native. You lose the native physics and the feel that people have come to expect out of these mobile platforms. And so Dropbox is taking a different approach, which is instead of going top-down, let's try building a shared library from the bottom up. So let's go back to C++, some C code, and try to write all of this shared logic that can run on both platforms. So the idea here is that the applications then become thin UI clients. They basically just interact with native UIKit, Android frameworks. They build up the UI themselves, and the data provider is beneath them. And we've kind of seen this happen with web development, where in the early days, web developers just did everything. They wrote the server code, they wrote the front-end code, and that's how mobile has been. It's been, engineering teams will build everything, both parts of the stack. And we're kind of building this separation of a back-end and a front-end on the client, where you can actually have some clean abstraction, a clean API, and you can have UI engineers really focusing on the user interactions and building really, really compelling UI, and have that decoupled from the work that needs to go into, somewhat decoupled from the work that needs to go into building the backend. And this is a model that has worked very well for us on the desktop client, because if you look at our desktop client that runs on Mac, Windows, and Linux, the shared syncing logic of syncing all of the data changes back to the Dropbox backend is written in Python. And then there are affordances that allow different UI for the different platforms. So we thought, if this can work for desktop, why can't it work for mobile? And that's what we've been working on with libdropbox. So if we look at the basic model here, we've got the user interface code at the highest layer of the stack interacting with the users. And at the bottommost layer, we have this shared C++ library. And then there's some bridging layer in between, where we actually need to expose an API that the app can communicate with and convert data types from C++ data types into native data types. So for iOS, that means Objective-C++, and for Java, that means a JNI layer. And one of the things that was frustrating in getting this project off the ground was writing a lot of boilerplate code to bridge the gap between native and C++. And we've been building some tooling around that, like a JNI generator that will actually automatically produce the JNI code that can glue the two together. So we don't waste engineer productivity on kind of boilerplate and plumbing. So the architecture of this C++ library is probably familiar to those of you that have been working on similar data model things for your mobile apps. So we have the Dropbox server, and that basically contains the truth. It contains all of the metadata about files and photos and all of the user data in Dropbox. And we basically just have a thread that is running in the library and constantly polling the server for updates. So we establish a long poll connection to the server. When something changes, the server kills the connection, so we know that we can query for an update. And then our updates are delta-based, so when we actually get updates of this photo was added, this photo was removed, this file has been renamed, we don't have to download very large payloads. We can only get the things that have incrementally changed since the last time that we contacted the server. And then once we get those updates from the sync thread, we just store those results into SQLite. And SQLite now becomes a cache of the truth of what lives in the user's Dropbox. And then there is just some API that allows the application to query for that data. So here's an example of what one of our C++ APIs look like. So we declare a photo listener class. And the expectation here is that in Java and in Objective-C++, we will define a subclass of the photo listener that actually implements this virtual add photo metadata method. And then the application just registers itself, this listener, as being interested in updates to the photo collection. So we have like a struct which is declared and defined in a public header so that the application can see all the fields that are in that struct. And then we just define some common types. And so now when we actually want to show photos in the grid, we can do a query in SQLite, iterate over all of the rows in the result, and then fill one of these photo item structs in C++ and call back to the listener that something has been added. And the reason that we've built this listener interface is so that when we get those updates from the server that a photo's been added, a photo's been removed, rather than forcing the app to requery for the whole data set, we apply the same delta methodology back up to the application. So now when we get an add on the server, we get down some JSON. We parse that JSON into one of these photo item structs. And then we're able to insert it into the cache and call back to the app that a photo has been added. And of course, we need to add to the cache first so that we never show the user a photo until we're sure it's safe on the device in the event of a crash or the user quitting the app or something like that. So now if we actually move into the native layer, we have some wrapper libraries that basically turn these C and C++ objects into native Objective-C and Java types. So here's a very simple example of a photo item implementation in Objective-C where we convert those strings and metadata objects and things like that from their C native types into NS strings and NS dates and all those native objects that we're familiar working with as iOS engineers. So the idea here is that whoever's building the user interface for the iOS app just sees regular iOS Objective-C objects that they're used to interacting with, and to them, it's kind of an opaque API, similar to interacting with like UIKit or Foundation or any of the Apple-provided API. So that's the basic model for just getting down data from Dropbox and providing it back to the application for display. So now if we actually want to add the ability to modify that data, we need to provide a mechanism for users to take action and basically perform operations on that cache. So we extended this picture a little bit, and we had two new pieces here, an operation queue and an operation thread. So the operation queue is just a queue. It's basically got a list of all of the operations that the user has taken on the device that have not yet been synced up to the Dropbox server. And then we've got an operation thread, which just polls that queue, sees new things coming in, and tries its best to upload those changes to Dropbox. So it sees that a deletion of a file has come in. It's just like, I'm going to try really hard to send that up to the server. So the idea here is that if the application now decides to query for the contents of the Dropbox and says, show me this file, or show me the contents of this file, show me the contents of this directory, rather than just looking at the SQLite cache alone, it will look at the SQLite cache and then apply all pending operations on top of that cached data set. So if you have data in Dropbox and you apply operations on top of Dropbox, then you'll get some state on the server. If you have a local reflection of the server state and then you apply the operations locally before you give that result back to the app, the idea is that you'll have eventual consistency between the server and what the application is displaying to the user. So here's a simple example. We expose a very simple file system-like API to the application. So the application developer can just say, I would like to delete this directory. And you'll notice that the application developer doesn't need to think about the network, doesn't need to think about what happens if that request doesn't succeed, what happens in the event the app crashes immediately after this line of code, et cetera. So all of that complicated logic is kind of abstracted away. And we go back to the very simple model of we have a local database, we have a local file system. We can just treat it as though we were on the desktop, the way that we used to be able to treat file systems before this cloud era. So what happens when we call this delete? We basically construct one of those delete operations and put it in the operation queue. And now when we actually want to list the contents of a directory, we get something out of the cache. And before we return that to the app, we walk through the operation queue. We look at what are the types of operations that are pending and apply basically mirrored logic of what the server will do when it gets that operation on the client. And then we pass the result back to the application. So this is all good and well, but at some point you have to say, are you going to re-implement the whole world in C++? And it's a little unrealistic to try to do everything in C++. So learning to set boundaries between what the application should be responsible for and what the library should be responsible for has been an interesting design challenge as we've been building this out. And one of the things is that the platforms already have HTTP request and response handling, SSL certificate verification, all of these things that are useful for actually making network requests. So let's not try to re-implement that in C++. Let's just provide a mechanism to call back to the app, and the app can actually perform the requests. So even though we're building in C++, our iOS application, for instance, can still take advantage of new APIs like the NSURL session API. So what have we learned from doing this so far? We've noticed that Android and iOS engineers are communicating better than ever because they need to be defining this shared API and making sure that it works for both platforms. And that's just a really good thing when you're trying to build a product that will work everywhere and provide a consistent user experience to your users. We've also noticed that we find bugs earlier. If a bug is affecting Android, it's also going to be affecting iOS. So when they fix that bug, it'll also benefit the other platform. Same deal with performance optimizations. You spend a bunch of time working through the data model and optimizing some SQLite queries, et cetera, and that's just going to benefit both of the apps. And one really interesting thing that we're able to do with this model is to actually test iOS code before we ship it to Apple. Because the pain of shipping a bug to Apple, of course, is the review process. And there is that emergency switch for when you really need to ask Apple to expedite something. But for the most part, when you introduce a bug, it means there's a high latency of your users dealing with that bug before they get a fix. So one of the things that we have for our Android users is a beta testing program where we distribute beta builds via our Dropbox forum. And what we can do is put some of this shared code into those Android builds, and we can validate it and test it at scale with those thousands of beta testers before we ship to Apple, which has been traditionally quite difficult for us on iOS because of the fact that we are still a very small company, and testing with even a few hundred iOS users is nothing compared to testing when you have the millions of users that we have. And at this point, I'm going to pass it off to Sean.
All right. Thanks, Steven. So I'll back a slide here. So I'm Sean. I'm actually the eng lead for Mailbox. And so what I want to do is just give a little bit different perspective and tell a story about how a small startup kind of arrived at the same conclusion, a little bit of perspective on how we landed there, and then talk about what we're doing and how we're moving forward and where that's taking us. So this is a story, sorry about that. This is a story about how we landed on libmailbox. So early in 2011, when we were starting Orchestra up, we had very limited resources. It was just a couple engineers. We also knew that we needed to fit as many iterations as possible into those early cycles. We were trying to figure out what our product was, how we were going to reach product market fit, how our product was going to evolve. And so we knew that we needed to move really, really fast. And so we had this vision the whole time of enabling quick development through a shared library. And our expertise on the team at the time was purely iOS. So what we ended up doing is taking the same idea of building a backend for your clients. And we separated out all the data logic, all the networking, put that in a static library. And this is somewhat of a common pattern that I've seen recently as well. But then the front-end application code was purely just drawing and calling into the API. So it forced us to build very clean abstractions and set us up for future endeavors past that. But the really important piece for us was that we were able to iterate really quickly to build our products. And so we used that model we had a static C++ or Objective-C library, and then our front-end code. And that is what brought us through the first iteration of the product we built, which is Orchestra To-Do. It was a collaborative to-do list oriented around making people more productive. And this worked really well. We went through, I don't know how many countless rewrites of this code as we were iterating through our product. And this is actually the same model we used all the way through building Mailbox. Mailbox is, we actually took the code from Orchestra To-Do, we kind of modified it, iterated on it, and still had that same separated model of a shared C++ or shared Objective-C library and the front-end code running on top of it. And for this one specifically, we went through, I think, like 20 different versions that we built on the front end. But because we were careful about setting those boundaries earlier and making those abstractions really clean on our back end on our clients, we were able to move really fast and reach this point. And the fruits of that labor actually came soon after we launched. Once it started to feel more and more like we had product market fit and we could start focusing on getting it into more people's hands, we used the benefits of having that clean abstraction to build out our iPad app. And we were actually able to build this. We didn't start building it until after we launched our application. And we launched it just, I think, like 5 weeks after we launched our iPhone app. And the reason we were able to move so fast on it was purely just UI work. All the data calls were exactly the same. All of the reads from the database were exactly the same. And I'll get into more detail of how we've structured that to make that move really quickly. And so as I said, as we started felt more and more like product market fit. This is a graph of our scale at launch. We went from processing almost close to 0 emails a day when our beta was in progress to 100 million emails a day and more in just 6 weeks. And so at that point, we kind of took a step back, realized there was less of those iteration loops needed to kind of keep working towards what we thought might be product market fit and let the product evolve from that iteration. And it made us realize that we needed to start thinking about how do we get this into more people's hands, as many people's hands as possible. We still had very limited resources. We were still just it was only 2 people working on this project at the time. And we knew we needed to expand out to Android, desktop, iOS, and whatever other platform came past that. So TVs, I don't know what the future is going to hold. So we knew that Objective-C clearly would not run on Windows or Android. It might, but it's not a feat that we wanted to undertake. So independently, we kind of thought, okay, this is independent of Dropbox coming to the same conclusion, but we thought, how do we take what we've already built, these clean abstractions that allow us to move really fast, and move it into a world where we can develop on all the platforms at the same time and get a lot of the benefits that Stephen was talking about. And so that's where we arrived at libmailbox. And the idea was build it once, build a feature once, and build really, really strong abstractions that allow each client to iterate very quickly to build these rich native applications where the user doesn't have to think about what's happening. Everything feels kind of magical, but also the developer who's building the front-end code doesn't really have to think about, okay, what's the state of the network? What do I need to do if this request fails? And when do I need to ask the database to redraw? So I'll get into more details of what that looked like for us. And I first want to take a step back and talk about some of the benefits there from the developer side. So one was that it lowered our development costs. We got to build it once. And we still only had 2 people working on this project, and we now had a lot more work that we had to support to get there. But it also reduced the developer complexity because instead of needing multiple experts to build this backend, we now only needed 1 expert. And so we added a few more people to our team, but it actually reduced the amount of scope that we needed to cover in order to move more quickly on more platforms. And the final one, which is the most important, which I've probably said too many times already, but it's really enabled, the benefits of this have been really surprising for us recently, and we've been very happy with where it's taking us. Just this ability to iterate and prototype and develop very quickly, even on things we're not planning on building right now. Because the core library, this libmailbox library, is so powerful, so strong, it just allows us to fire up in just a week, prototype a desktop client or prototype some idea we're trying out for Android because all of the work's already been done to refine the experience for iOS. So I want to talk a little bit about the architecture that we've used. This is the slide from Stephen earlier. And we had this, after we got acquired, we started looking about what Dropbox was doing here with libdropbox as we were having the same ideas and starting to think about the same direction. And a really awesome realization for us is that our architecture was almost identical. we have one source of truth, which is our SQLite database. The one subtle difference is we don't apply changes on the operation queue. We treat the phone source of truth and have the phone and the server as a source of truth, and then we kind of resolve conflicts through these managers that exist on the side here that are handling all of the offline syncing, all of the conflict resolution, anything that needs to be brought back to the user in any way. So that was really powerful for us, and I actually wanted to hit on a few quick things about what we did and key learnings we're taking away from that as we move forward. So the first is to keep that data layer extremely simple. We were inspired by core data. We were traditionally iOS developers. But there's a lot that comes with big, heavy frameworks that either slows you down or just distracts in some way. So for us, we really wanted to focus on building a really, really thin layer that was really powerful, but just didn't do more than it needed to do at all. So keeping this one source of truth, the SQLite database, whether it was a user action or an action from the server, everything was just extremely simple, funneled into the same database, so that the application building didn't need to worry about, is this data out of sync? Are there two copies? Do I need to look in this other place to merge this piece of data together? It was all always in one place, and the logic around it made sure that that data was always consistent. And similar to a few other talks earlier, we have one sync thread that we just funnel all of our operations, whether they're from the user or from the server, through to make the complexity of reasoning about these things super low. So the other one is, which even Stephen hinted at, was use the OS networking libraries. So there's a lot, the SSL, caching, other kinds of stuff. But for us, it was when this is possible. So Mailbox, we had this goal from the very beginning that we wanted to eliminate the refresh button. We felt it was a little bit antiquated. You use your SMS app. You never have to think about, oh, do I have the data that's there for me? It's kind of, if the data's sent, you have it. So we felt like that was the direction of mobile. That's the direction mobile needed to go. And so we wanted to build something that enabled that. So we don't run on any kind of long polling. Everything is run over WebSockets. And so since it's a new standard, there's no native support in Cocoa, and in Android, it was pretty buggy at the time that we were building it out. So we've built WebSockets in C++, which has been a tremendous developer productivity boost for us. So instead of having to worry about these bugs on multiple platforms, learning the network stack on both, and implementing WebSockets on top of it, we were just able to build it with sockets, keep it super simple in C++, and move forward from there. And the last one, which is probably my favorite and one that's been really important for us, ties back to this iteration theme, is that real-time data APIs are awesome. And that's kind of nebulous. What does that actually mean? And what I mean by this is, in your application, in this core shared library, building mechanisms that make front-end development super easy by always notifying whatever that view is concerned about only for what they need to be changing. And I want to walk through an example here of how we did this. So this is our inbox view. This is just your emails that are in your inbox that you need to pay attention to. So what we do is in libmailbox, you register whatever view wants to draw some set of data. You register a SQLite query with the database. And so it will return you results, but at that point, it sets up a bidirectional communication pipe that says, hey, don't worry, I've got your back. Anything changes, I'll let you know exactly what happens. This is really powerful for us because whether it's a user action being submitted, so for a front-end developer, all he has to say is, hey, this thread, archive it, his work's done. From that point forward, he doesn't have to worry about anything else. Or if the action comes in from the server, these both funnel through the same pipe. And what we do is libmailbox takes that query, reruns the logic, and figures out, OK, this guy's listening to this SQLite query, but I've noticed that these 5 updates cause items at index 0, 5, and 6 to change. So it'll send back an update like insert an email at index 0, or redraw the red on red state at index 5, or move index 2 to index 6. And anyone that's familiar with core data, this is very much inspired by that system, but we try to eliminate a lot of the unnecessary cruft with merging contexts and doing all the complicated logic, and keep it super simple so someone's just registering and responding to updates. So when our front-end developer is building this interface, they don't have to worry about at any time needing to know when to redraw, because they know at any time the source of truth changes, they'll get told exactly what to redraw. This actually makes this incredibly powerful for us. It allows us to iterate really quickly and go through this cycle numerous times while we're developing. And you can just spin up a view in 5 minutes and have a real-time updating, fully functional interface to start playing around with and prototyping different features, different aspects of that view. And so this cycle is really important to us. It's the ability to prototype, get feedback, rethink and reevaluate, and go back over and over again. And that's set us up to be able to run really quickly in parallel on Android and iOS. We haven't released our Android app yet, but we've been really happy. We've been making a big upfront investment in libmailbox and getting it up to speed to enable this development. We've been kind of blown away by how fast, with just 2 more people added to our team, we're able to run developing this without even faster than we were when we were focusing on just one platform. So this has been great for Mailbox, but I want to tie this back into Dropbox and talk about something that we're really excited about and something that's really interesting. The story for Mailbox was a small team, limited resources. We're looking at millions of users. As we get into a bigger company and start thinking about getting our product into as many hands as possible, we really needed to think about this cross-platform experience. But at Dropbox, we're not naive. We've been through this process a few times with Dropbox, with Mailbox, with other products, and we know that this experience of getting these products off the ground, building all of these offline sync experiences, all the database logic, all the networking, everything that comes with it, is really hard. And so something that's really interesting about everything we've talked about, or everything that Steven's talked about, is that exact same code that we're using in that shared lib Dropbox C++ library is the exact code that runs in our developer library that we distribute. So our developer SDKs, our data stores, everything is the same, developed by the same team. All the big bug fixes that go into our product go into the SDKs. It's a really powerful thing that we hope will start enabling lots and lots of developers to get their complex applications off the ground quickly. And so instead of having to worry about, the analogy here is Dropbox, traditionally you're saving to a file, but as sync becomes the new save for every application, we hope that we're able to enable lots of developers to be cross-platform from the very first day that they begin developing. So thanks for having us up here. We're really excited about where this is taking us, and we're actually really interested to see what other companies are going to be doing. Our emails are up here. We'll be around afterwards to answer any questions or to follow up on any specific ideas or anything else. But I think we have about 10 minutes left. We can take any questions now.
So for iOS, I can see that going with this concept of building a native library in C++ and building a UI, there won't be any performance hit as such because they are compatible. But in Android, going through the JNI layer and the binder and all, do you see any performance impact there?
It's definitely a lot harder. I'll answer this first and let Steven take it over after that. This is something we've been deep in recently. Developing Android or Mailbox for Android, and it's definitely something you really have to pay attention to. And you get subtle costs like parsing JSON becomes your most expensive thing that you're doing, even though the amount of data is just like this long, and it actually will cause jerks in your UI, drop frames. But we fortunately have some really smart people that know the system really well. And the other model that we toyed around with that we might end up using is the UI in Android might be able to talk directly to the database and have some kind of bridge there so that you eliminate that cost whenever you're reading, and you only incur the cost when you're writing, but the writes don't matter because it handles all of the conflict resolution and all the offline writes. So it's kind of like write and forget, and then the UI handles everything past that. So it's still yet to be seen, but we're seeing really awesome performance.
How can you do it in SQLite? Means directly Java layer talking to the SQLite database?
Do you know how to answer this?
Sorry, could you repeat the question?
So as you said that in in Android you you have built some interface so that SQLite database is directly talking to the UI. Means UI is directly talking to the, not SQLite, some database. So what the database is.
I see.
Means native is writing some database and some database is accessible in UI in Android. How it's possible?
I'm not an Android developer, so I don't know the exact how we would do that. And it's an idea we've toyed around with. We haven't actually executed it. But the idea would be you write some way in Java to access the database file directly. I don't know what that would actually look like in practice.
One of the things that's interesting as well for Android is that Java objects that are passed back through the bridge all have to deal with garbage collection. If you can allocate the bytes in C++ and not copy them through that bridging layer, then you can actually do some interesting things around memory mapping and not having to pay the cost of garbage collection and boosting your memory footprint of your application.
So this common library in C++ sounds awesome, and I like it. If I want to use it, I just get your SDK and pick it out from there. Pretty much all this lib Dropbox, lib Mailbox is in the SDK.
Yes, so dropbox.com/developers. On there are two SDKs. One of them is called the Sync API. That provides the illusion of reading and writing files. So it's basically a replacement for a file system API. There's a second SDK, which is our data stores API. And that's similar to a database. So you have tables with records, and same idea applies, where you can treat it as a local database for the most part. You can write changes, read changes out of it. And there are Objective-C and Java wrappers that you just interface with directly. There is, with the data stores, some conflict resolution policy as well, because you can have records that get out of sync between the server and the client. Right now, those conflict resolution policies are pretty simple. But we're going to be continuing to extend the data stores API and continue to grow it out. So it was in beta for a long time. We announced it a few months ago at our first developer conference called DBX. And it just went 1.0 a couple weeks ago. So we'd love for you guys to play with it and give us feedback.
Okay, so I have one question. For the feature which involved both on iOS and Android, how do you guys allocate the resources? More specifically, is that one developer for iOS, one developer for the Android, and one developer for cross-platform? Yeah.
I think our stories are going to be different. Our team's a lot younger still, and our product is generally a lot younger. So for us right now, we have one person devoted on Android, one person that does iOS and Android, and then one person that does iOS and builds lib Mailbox. So that's our current allocation, but it's very different for Dropbox. And I'll let Steven take over.
On our team, we've had mostly mobile engineers that have experience with Android and iOS, and they've been diving into the C++ layers to build the backend. So we've been kind of learning C++ as we go in some ways and making all the mistakes that you can make with C++ because it is a very complicated language. The way that we've structured our team is we try to define a clean abstraction and a clean API that will enable a user interface engineer, if you will, to build out the UX and build out the product in the iOS side or in the Android side. And they're communicating, of course, with the person implementing the API and implementing the lib Dropbox side of the world. The same as you might have a separation between someone building a REST API on the server and someone building a mobile client, or someone building a REST API on a server and building the front end of a website. So yeah, we've had people kind of working across the stack, but we've also been increasingly getting towards a place where we can have clear lines of abstraction and people allocated on opposite sides of that fence, if you will.
Just a quick question about the subscribers to the change notifications. You talked about centralized truth and the store, and it notifying a given view or interested party of changes that may be relevant after the registration of what it has interest in. Could you elaborate a little bit more on the basic mechanism that you filter out that kind of communication, make sure that the subscriber's getting what exactly they want with all the things that are going on?
Yeah, I think the clearest way to describe it is it's just ensuring that the SQLite query is in sync. So we're actually really heavily relying on SQLite, the query engine there, to get things right. But lib Mailbox has a lot more. It knows which things are cached. It knows what it can access very quickly, what it needs to query in the database what was just recently written that's in memory that was just written out to the database, so it can run like in-memory SQLite logic. And so it's basically just taking two different results, rows, and figuring out the logic there. And then it's just kind of, taking the code forward. Yeah.
And what this has meant on the Dropbox side is the way we've been building our API is to register listeners on different resources that you're interested in. So actually, if you go look at our developer SDK, you'll actually see that you can register listeners, and you can register a listener, for instance, on a path or on a directory and all of its children. And you just get a callback when those things have changed. So we've actually been pretty inspired by like some of the stuff that Mailbox is doing and wanting to make this listener model a little more generic. But right now it's kind of one-off on a per API basis. We're registering listeners on various resources.
I think we're actually going, it's kind of a mix of that too. The idea in the long run is to have kind of roles that are defined to enable more developers to jump in there more quickly instead of having to figure out what's the SQL query here or writing a really slow SQL query that hits performance somewhere else. And then one other thing that I didn't mention that we do is we provide the ability to kind of pause your listening. So in Mailbox, you have your inbox view, you have your archive view, and your deferred view all right there, and you can switch between them really quickly. So we keep those in memory, and we just animate them over. But on Android, for example, we saw some performance problems by keeping them all updating and live at the same time. But we didn't want to have the front end to have to worry about, all right, I need to like reset up this entire view. So what it'll do is when that goes off screen, it'll just say, I want to pause. And before it gets brought on screen, it'll tell the Mailbox, I want to resume. Just give me the change set since I was last listening. That's been really good for our performance so far.
Well, is there somebody over there? Okay, I'll go ahead and ask. Actually, one of my questions was about this notification mechanism and how, and you answered that the fact that you pause it because, so are you using notifications on iOS or delegates or blocks, or what's the mechanism for informing the UI back?
It's delegate based.
Delegates. Okay.
Yeah. So have you used Core Data at all?
Yeah.
Yeah. So it's just gosh, what's it called? The NS managed object. I don't know. The thing that notifies you of the changes. We use that model.
Right.
Yeah, that one.
And another question I had actually had to do with when you're trying to query if the server is the truth and multiple things are going back and forth between them, do you guys do things like transactions and things like that to make sure the data integrity is there, or if because the user the line can drop in the middle and then you're in the middle of sort of half-baked
stuff?
So
we do use transactions for writing into the cache, and like whenever we create an operation, we make sure to persist it so that if in the event of a crash or anything like that, we have good data integrity. The other thing that I kind of skirted around in the talk is the fact that you can have incoming operations from the Dropbox server that conflict with things that are in your operation queue. So we have a massive function that deals with resolving those conflicts and figuring out what the appropriate thing to do is based on the operations.
We have similar conflict resolution on the Mailbox too.
And I think we're out of time, but we'll be around afterwards. So.
Round of applause, please, for Dropbox. Thanks, guys.